Hello. If you're hearing my first few words, you might be watching on the recording, and if so, welcome. I'm going to allow a few people to connect in real time live. Hello, if you're joining us, nice to have you. Hi, good morning. It's morning where I am. You might be in a different part of the world. My name is Melody, and here we're going to talk about some tips today that can help you to make algebra a lot more approachable on GRE quant problems. So while we're waiting for everyone to join and get settled, if you want to grab some paper and something to write with to take notes and try out practice problems, this is your reminder to do that. Grab some scratch paper and we will work on some algebra problems. But we're not going to use any algebra to solve them. It's going to be great. All righty, so we've got a couple who've joined. Hi, nice to have you with us. Let's get started, and anyone who joins later on can always catch up on what they've missed. Today, we're going to talk about some advice, and we're going to do some practice that will help you to make algebra problems on the GRE a lot more approachable if you're someone who struggles with algebra or tends to make mistakes. Even if you're not, this strategy can be really helpful in giving you the opportunity to be accurate and quick on a lot of different problems. So we're going to choose our own numbers. We're going to pick out numbers to solve algebra. A lot of us in school said, oh, algebra, why are there letters? So we're going to kind of fight the battle against letters in math in today's discussion. So thanks for joining. Here we go. My name is Melody. Hello. I'm one of the instructors here at Magoosh, also a content creator. So you might have heard my voice or seen me around different forms of social media. Want to let you know that I am a math teacher and I've been tutoring all sorts of things since I was, in middle school, a very long time, because we don't need to talk about how old I am. Very, very long time. The reason I mention that is that I want you to know that I have a lot of experience seeing things through the student's perspective. I understand what common obstacles there are, what things might make it frustrating for a student, and I want to use that experience to teach you things in ways that are as helpful as possible for you. I'm in the Tampa, Florida area, and I live here with my husband and no pets currently, but that's okay. So I'm curious, where are you joining from? If you'd like to share that in the comment section, feel free to let me know where you're joining from. Say hello, and I would like to invite you to feel free to have a discussion with me during today's stream. If you have questions or comments, if you would like for me to repeat or clarify something, please let me know. I'll also throw out opportunities for you to think and reflect on what we're doing or to try out practice problems. And if you would like to participate and actually respond to those questions I'm asking, you can use the comment section. I will be watching and following along live, and I'll be able to respond to you. All right. So here, what are we going to be doing? We're going to talk about smart numbers as they apply to the technique we're learning today. What kind of numbers are the best choices to help us hack these algebra problems? We're going to see how we can kind of avoid using actual algebra when solving certain algebra problems. And we're going to try to navigate any possible traps or issues with this technique and just overcome them and be great. We're going to do this mostly through practice problems. But before we start on some practice math problems, let's talk about the technique itself. It's called plugging in numbers. And this technique can also be called picking numbers. Plugging in really captures the spirit of what we're going to do. Wherever we have letters in algebra, we're going to plug a number in instead, and that's going to help us out. Here's what you need to know. It's a technique that involves choosing your own numbers to plug in. That's where the smart numbers will come in. And solving algebra problems using arithmetic or basic math. Arithmetic is everything we did before algebra, working with numbers, adding, subtracting, multiplying, dividing, and so on. Your clue that this strategy of plugging numbers is an option Your clue is when you see variables in the answer choices. AC here stands for answer choices. So if you're working on a problem on the GRE, maybe it's multiple choice or multiple select, maybe even quantitative comparison, and there are variables in the answer choices or variables in the columns on a QC question. Look for opportunities to use this technique. It might be able to help you through a lot of questions in less stressful and more accurate ways. Here are the basic steps that we're going to need to follow. Number one, you have to pick a number. And I'm so sorry, but something's going on in my screencast here. I'm going to read you what this is supposed to say. Pick a number that's easy to work with and follows the rules in the problem. Follows the rules. There we go. Follows the rules in the problem. What does that mean? If the problem says we're talking about a negative integer or a multiple of 3, you have to follow those rules. Also, if it talks about something like the number of people or the price to buy an object, you have to use a little reasoning. Well, a number of people has to be a whole number. We're not going to say fractions. And if we're talking about the price of an object, we need a positive number. So honor the problem as it's described, but really you want to pick numbers that are going to be easy for you to work with. And I want for every variable you pick a number for, write down on your scratch paper what number you picked. Here are some good, smart, easy numbers to use. Some of our very favorite easy numbers to use in anything are 0 and 1. They can be great options. Sometimes you might need a positive even number, so we can add 2 to the list. Some questions might require a negative. And some questions might require a fraction. So our favorite fraction, the one we're most familiar with, is 1/2. This list can be some inspiration to help you pick the easiest possible numbers to work with. But again, always honor the rules in the problem. If we need a multiple of 5 or something like that, follow what the problem says. And here's another great tip. If you're working with percents, remember percent means divided by 100. That's what the word percent means. So if you're going to have to divide something by 100, let it be a multiple of 100. So a number like 100, 200, 300 is a great number to plug in on percent problems. Step 2, after we've chosen those numbers, is we're going to plug those numbers in for the variables in the original problem and solve the problem. Find the numerical value that is the answer. We also want to write this down and make sure that it's very easy to find on your paper. I like to put a star by it or circle it, draw a little box around it, something that makes it stand out on my scratch paper. Step 3, we're going to take those same values that we picked for the variables, plug them into the answer choices. Again, AC for answer choices. Each of the answer choices. And POE. POE stands for the process of elimination. What does that mean? That means we're going to plug the numbers in. If they match the solution number we found, great. If not, we're going to eliminate them. We're going to cross them out. On your scratch paper, I like to actually write down the letters A, B, C, D, and E since we're talking about a computer-based test. And I will cross out the letters that don't match until there's only one left. Now, because you picked your own numbers, it's possible once in a while that you won't have only one answer choice left at this point. So it's not going to happen super often, but let's discuss if that does happen. If you're not down to only one answer choice, no problem. Still eliminate the ones that didn't match. Those are eliminated forever. Pick a different value for the variables and repeat the process. It'll be faster the second time because you already know what the calculations are like, and only test the answer choices you haven't eliminated yet. So if that happens, there's your surefire way to get a right answer. That's our plan. So far, just a quick pause in the comments. Are there any major questions about what we've discussed that you'd like to ask me at this point? If you just want to see it in action, that's the very next thing we're going to do. So quick break to invite any questions. And hello, Emmanuel, joining from Ghana. Thank you for letting me know where you were joining us from. I think it's super cool that we can be in different countries, different parts of the world, and connecting to do some algebra together or to not do some algebra together. Okay. For the rest of our time together, we're going to be working on practice problems. So like I said, grab your scratch paper, follow along with me. I'll give you time to actually practice these problems, and I'll guide you through learning to use the technique through practice. So that's what we're going to do. We're going to practice. Here's our first practice problem. I'll give you a moment to look over it. And it says the wholesale price, I'm having display issues again. There we go. The wholesale price of a new laptop is P dollars. We see that variable there. The laptop is sold at a retail price 60% greater than the wholesale price. During a sale, the price of the laptop is reduced by 25%. What is the sale price of the laptop in terms of P? Before we start working on anything, I want to point out that we can use the plugging in numbers technique, and here's how we know. Remember the clue I told you to look for? So in the purple on the left, it asks, what is our Q that we can plug in here? The clue I told you to look out for is when you see variables in the answer choices. So what's our variable in this problem? It's P, the letter P. And all of our answer choices include the letter P, don't they? All of our answer choices include the letter P. So this question is a good candidate for the plugging in numbers technique. There are other ways to solve it, absolutely. This is also a question that many students tend to make mistakes on. Anytime we have a sequence of percent changes, students tend to make a lot of common mistakes. So let's see if we can use our plugging in numbers technique to avoid mistakes and get the right answer. Next thing we need to look at is the rules of the problem. What kind of numbers can we plug in? Well, we don't have anything directly stating requirements, but we do need to think critically for a second. We're talking about the price of a laptop computer. So that price, the money you have to pay, logically is going to be a positive number. Does that make sense? You're not going to have a zero price. And if you tried, you're going to have a lot of inconveniences working out this problem. You won't have a zero price. You won't have a negative price. The price is going to be a positive number because that's how we sell things. We charge positive amounts of money. Great. So let's try it out. Here we go. We can plug in whole numbers. We could plug in fractions if we want. We need to plug in a positive number. We cannot plug in a negative number or zero. But we want to pick a smart number. We want to pick a number that is going to make this problem easy for us to work with. And there was a clue for what to choose when we work with percents. So take a moment and pick out what number you think would be a good idea to use. And a number in the comments so I can see what you're thinking. Since we're working with percents, a very convenient number to use would be a multiple of 100. In fact, I'm going to use 100 itself. So my smart number is going to be that P equals 100. That's the number I'm going to plug in. And remember, write that down on your scratch paper. Now let's solve the problem. So our computer screen is represented on the left. On our scratch paper, we're going to write down P equals 100. The wholesale price of a new laptop is P dollars. Now it's $100. The laptop is sold at a retail price that is 60% greater than the wholesale price. Here's the beauty of picking an easy number. What is 60% more than 100? Well, 60% of 100 is 60. If we break 100 into 100 parts and take 60 of them, 60% of 100 is 60%. So if it's going to be 60% greater, that means we're going to have the original price, 100, plus a $60 increase. $160 is the retail price. Then we're going to have a sale, just following along in the problem. During a sale, the price of the laptop is reduced by 25%. So we'll start at that retail $160 price, and we need to subtract 25%, or 1/4. Perhaps you notice that 160 is just 16 times 10. And 1/4 of 16 is 4. So 1/4 of 160 is $40. If that's not easy for you to see during the exam with a little mental math, easy to work out on a calculator using the on-screen calculator. So 160 minus 40 is $120. That's the final sale price, and that's the one that we want to make sure stands out. Our final step is now going to be to compare that with the answer choices. So what am I going to do? I'm going to take my answer choices. I'm going to plug in P equals 100. So what's going to happen? Answer choice A is going to become 1.1 times 100. Easy to calculate, right? Multiply 100 just means move the decimal point. So that's $110. 1 is 100. In fact, many of us probably don't have to actually work out all of the answer choices to see what's going to happen. Look what happened. 1.2 times 100 is $120. That's exactly the same as that target value we were looking for. And we can see by looking ahead at the remaining answer choices that none of them are going to come out to be the same. So our correct answer here is 1.2 times P. Again, is there another way we could have solved this? Sure. And some of us could do so accurately. Some of us would struggle or find it stressful. Even if you are very good at working with percent changes and multiplying to get the answer algebraically, it could be that plugging in actual numbers is going to be a little bit faster and a little bit simpler. So I encourage you to get to know this technique and try it out on many, many different questions. Get a feel for how it can help you have an alternative way to solve algebra problems. So what did we do? Step 1, we picked out a number that would be a good, easy choice to work with. Step 2, we solved the question using our plugged in number. Step 3, we used the process of elimination and plugged that number into the answer choices. We didn't need to get to step 4 because we were already down to one answer choice. We're going to repeat the process again on practice problems. As I go, please feel free to ask me questions in the comment section. Here's our next practice problem. This one might not be quite as easy. This is an integer properties problem, and a lot of us might not have a great plan for exactly how to go about solving this. It says if m is an odd integer, which of the following must be an even integer? And if you're early in your studies, I want to point out that integer is a word that comes up a lot on the GRE. It basically means a whole number, but that whole number could be positive or negative or 0. But it's not a number that has to be written as a fraction or a decimal. So what's our cue? What's our clue that we could plug in here? Again, we see variables in the answer choices. The letter M is in each of the answer choices. That's a clue that we can use this technique. So we need to pick out a smart number. And before we do that, what does the problem say? This time, we do have a direct stated restriction. It says that m is an odd integer. So to be successful, we must pick an odd integer. Otherwise, if we pick an even number, we can't trust the answer. We might get an answer, but it won't be the answer to this question. We have to honor what the question says. Now, can we plug in a fraction this time? No. Could we plug in either positive or negative numbers? Sure, odd numbers can be positive or negative, but positive is going to be easier to work with. Most of us would agree with that right away. We cannot plug in even numbers this time. So we ask ourselves, what would be a smart number for me to plug in? What would you choose? It has to be an odd number. It has to be something that's easy to work with. You might want to pick something like 1 or 3 or 5, some small, easy to work with odd numbers. Some students are very hesitant to use 1. Can we use 1? Sure, it's an odd number, isn't it? And so for this problem, I'm going to use m equals 1. Now this time, if I plug that into the question, if 1 is an odd integer, which of the following must be an even integer? There's no math to do in the question this time. All of the math is going to happen in the answer choices this time. But I would probably note on my scratch paper that my target, my goal, is to find an even integer. That's what the answer choices have to be. So if I plug in m equals 1 and it's not even, we get rid of it. Answer choice A, m squared minus 6. No need to think too much about what that really means. We just plug our number in. So m squared becomes 1 squared minus 6. 1 squared is 1, and 1 minus 6 is negative 5. Don't stress about it being negative. Just ask, is this an even number? No. So we eliminate A. We're never going to think about answer choice A again. B, 5m plus 10. That becomes 5 times 1 plus 10. 5 times 1 is 5, and 5 plus 10 is 15. Is it even? Yes or no? No. Eliminate B. Answer choice C. 10m plus 1. That equals 10 times 1 plus 1, which is 10 plus 1, which equals 11. Is it even? No. Answer choice D. 30m over 7. That's 30 times 1 over 7. 30 divided by 7, you might say, I don't know what that is. It's going to equal a fraction or a decimal. Good. You don't have to keep going once you recognize that. The question is this an even integer? And this number isn't going to even be an integer at all of any type. This number is not an integer. So we eliminate D. Finally, answer choice E. At this point, if we've eliminated A, B, C, and D, if you were really rushing and you felt that you had done a good job so far, you might just choose E and move on, but it's only going to take a very quick moment to verify E. E is 2m cubed. So that's going to be 2 times 1 to the third power. 2 times 1 is 2, so 2 to the third power equals 8. There's my even integer. We found it, and the correct answer is E. So again, what have we done? We picked out, first we noticed that we can use plugging in. We picked out a number that would be easy to work with and followed the rules in the problem. Then we took that number to the question, and this time didn't have to do any work with the question. We tested all 5 answer choices, And when we were down to just one correct answer, we were finished. All righty, here's our next practice problem. If 5r is less than 2t, which is less than 0, which of the following must be the greatest? Again, not a lot of math to do in our question this time, but we're looking for which must be the biggest, the greatest out of the answer choices. So a little bit different from what we've seen. How do we know we can plug in variables in the answer choices? How are we going to pick smart numbers this time? There aren't any stated restrictions in the problem, but we do have some rules we have to follow. Think about it for a second. What type of numbers do you think we could plug in for r and t? The important part that hopefully you're seeing is we must plug in negative numbers. We have to. Why? Well, we need 5r and 2t to both be less than 0 or negative. So if we multiply 5 or 2 by something and get a negative result, then that variable must also be negative. The other rule that's not directly stated that we have to follow is we have to make sure that whatever we pick for r and t, that 5 times r is going to be less than 2 times t. And that's not complicated. We can find numbers pretty easily. But if we don't make sure that 5r is less than 2t, which is less than 0, then again, we can't trust the answer. So what could we choose? We want definitely negative numbers. They could be odd or even. They could be fractions. But we want to choose something easy to work with. So think about for a moment, what numbers would you choose for r and t? There are definitely many, many options. But think about what would be the easiest for you to use. My suggestion is going to be that r equals -1 and t equals -1. Many students working on this problem say, you can't do that. So my question to you is, why not? Does it feel weird to make them the same number? Maybe. But we are allowed to let the variables have the same value. That's one option, unless the question says otherwise. So unless the question said something like r is not equal to t, or r is greater than t, or r is less than t, we're allowed to make them the same if we want to. And in this case, making them the same number is going to make the calculations as easy as possible. Let's double check that that satisfies the original requirements. We need 5r is less than 2t is less than 0. That would mean 5 times -1 is less than 2 times -1 is less than 0. -5 is less than -2 is less than 0. That's true, because the bigger a negative number is, the smaller that number really is. So -5 is smaller than or less than -2. So our smart numbers, I'm going to use r equals -1, t equals -1. I'm actually going to give you about 30 seconds to try this problem out on your own before I reveal the answer. See how far you can get in eliminating answer choices for about 30 seconds. All right. Hopefully you've been able to eliminate one or two answer choices so far. What's our goal? What are we doing to determine which one's the answer choices? We need the one that is greatest. So I would probably note that on my scratch paper so that I don't lose focus. Answer choice A, 2t minus 5r. 2 times negative 1 is negative 2, minus 5 times negative 1 is negative 5. Careful there. Subtracting a negative is the same as adding. So negative 2 minus negative 5 equals negative 2 plus 5, and that equals 3. So far, can we tell if this is the greatest? Absolutely not. We're just going to have to compare it with the other answer choices, and that's okay. Answer choice B, 5r minus 2t. 5 times negative 1 is negative 5, minus 2 times negative 1 is negative 2. Notice the calculations were very similar. We're just going to end up a little bit different. So this is going to be negative 5 plus 2, which equals negative 3. Now we can at least compare these two. We need the greatest. So the one that's smaller can't be it. At this point, we can eliminate answer choice B. Answer choice C, 5r plus 2t. So 5r is negative 5 plus 2t is negative 2. We're getting good at multiplying those by now. Negative 5 plus negative 2 is negative 7. That's even smaller still. So we eliminate C. It's not going to be the greatest. Answer choice D, negative, parentheses, order of operations is important here, 5r plus 2t. So I would just keep those parentheses for now, sort things out for a minute. But I just figured out what 5r plus 2t is in answer choice C. Did you notice that? C says 5r plus 2t, and we already figured out that C equals negative 7. So negative 5r plus 2t equals negative 7. And a negative of a negative is a positive. This equals positive 7. How does that compare with the other answer choices? This one is the biggest so far. It's bigger than A. So now we can eliminate A. And finally, answer choice E requires no calculations. It's just 0. So we can compare directly. What's bigger, 7 or 0? Definitely 7. And the correct answer is D. Did you get it? Or did you start to get the hang of this technique? We've done several examples so far. In all of them, is there another way to solve the problem? Yeah. In fact, there are multiple ways to solve any math problem. Teachers don't always like for you to think that way, but I'm here to tell you it's true. There are many, many different ways that you can solve any math problem. So one key to success on the GRE is using the method that's the best for you, that helps you get right answers with high speed and low stress. So let's take a moment and invite any questions or comments you may have so far before we continue with a couple more practice problems. Questions or comments are welcome. Coffee is also welcome. Anybody out there sipping your coffee along with me? Where I am, it's 9 a.m. Ooh, but it must be a very, very different time of day in Ghana. Gosh, I'm thinking maybe 6-hour time difference, or a little more or a little less. Interesting. And often we have students joining from like 12 hours ahead of me. So whatever time of day it is for you. All right, don't see any outstanding questions. So in this last part of our discussion, we're going to take our time and look at some possible complications to this technique. Something that could feel like it's going wrong on the test, but we can absolutely overcome it. We just need to be strategic. So really, we're going to be focusing on that step 4, which was if you're not down to one answer choice, what do you do? And we have a couple of example problems that are going to kind of lead us to things not working out great right away. And that's okay. Our main takeaway from these remaining practice problems is that it doesn't have to always work out flawlessly on the first attempt for this to still be a really good technique, a good option. So here's our next practice problem. I'm going to give you about 25 seconds to look over it on your own before we discuss together. So now I'm going to stop asking, how do we know we can plug in our own numbers here? Because you need to start recognizing for yourself when there are variables in the answer choices that this is an option. Some students wind up using this at every possible opportunity. Other students don't really love this technique, but they learn it as an option on questions where they're really not sure what to do. And most students fall somewhere in the middle. We'll use it sometimes, but not every time. The point is, if you learn this technique, you have it as a tool ready to use. So look for opportunities to practice it. Here we have, Paula has T tokens. If G tokens are green, what percent of Paula's tokens are not green? So if you tried to approach this algebraically, even those who are very strong in algebra might find that it's a little complicated and it would be easy to make a mistake. So what we would need to do is say G tokens out of T are green. We would need to convert that to a percent. So that's where the hundreds are coming from in the answer choices. And then we would need to subtract that from 100% to get the leftover percent that are not green. Can it be done? Absolutely. But some of us might not really know how to do it the right way. Others might find it tedious or time consuming, or we might make mistakes. This is a great candidate for using our plugging in technique. So what numbers would you use that are easy, easy, easy? Our hint for percents was use multiples of 100. So let's say Paula has 100 tokens. T is 100. And then G, excuse me, G is going to be just a portion of those tokens. So we want some of them green, some of them not green. Maybe the easiest, most direct thing we could possibly think of is, let's say half of them are green and half of them aren't. Our favorite fraction is a half, right? That would mean that 50 tokens are green. All right, so if T equals 100, Paula has 100 tokens and half of them, or 50, are green. The answer to our question, what percent of Paula's tokens are not green, is going to be 50%. That's the answer. That's the number against which we test our answer choices. So, going to give you a little bit of time to try to work this out on your own. You're going to plug in T equals 100 and G equals 50 to all 5 answer choices. And you're going to eliminate the ones that don't match. This can take a little bit of time, So I'm going to give you about 1 minute, and I'm going to work it out on my scratch paper on the side so that I'm also seeing how much time it takes me. And then we'll come back and discuss together. If you need more time, I'll give you more time. Try it out. Plug these numbers into the answer choices. Now that I'm doing it, I see that 1 minute isn't quite enough for us to try this out. So I'll give you a little more time. All right, I'm going to give us about 20 more seconds. Okay, now I intentionally took the time to really finish every answer choice because I think that's what some of you might be doing if you're new to this technique. And you might not have finished all 5 yet. So this might feel like, doesn't this take longer? Isn't this a bad technique? I want to talk you through using the answer choices to test and show you how this should actually happen on the exam so that it doesn't take longer than it should. So we have t equals 100, g equals 50. We wrote them down on our scratch paper because we don't want to forget. If we scramble the 2, we'll get wrong answers. Let's try out our answer choices. A, 100t is going to equal 100 times 100 over t minus g, 100 minus 50. Now, big numbers. If we start plugging into calculators, things could get complicated quickly. A good idea is to simplify as much as you can mentally or by hand without going to the calculator because that will slow you down. And we don't actually care about the value of most of the answer choices. We don't care what it does equal. We just care whether it equals 50 or not, because remember, that's our goal. Test the answer choices. Do they equal 50? Yes or no? So here I can see that I'm going to have 100 times 100 over 50. And maybe we could recognize that 100 times 50, or 100 divided by 50 is 2. 100 times 2, is that going to equal 50? No. As soon as you know the answer is no, eliminate that answer choice. It doesn't matter what it does equal. So that's one way we save on speed. B, 100 times g times 50 over t, 100. Hey, look, the 100 on the top of the fraction and the 100 on the bottom cancel each other out. This does equal 50, and that's awesome. But the advice is we need to test all 5 answer choices. Need to test all 5 to be sure. So we'll keep B for now. We're not going to eliminate it, but we need to test the others to be sure. C says t minus g, 100 minus 50 over 100 times t times 100. That's 50 over 100 times 100. Whatever it is, if I take 50 and I divide it by some multiple of hundreds, it's not going to equal actually 50. I'm cutting 50 into pieces here, so it's not C. D. T 100 over 100 times T minus G, 100 minus 50. Well, the 100 and the 100 are cancel out. I have 1 over 50. Nope, that's not it. That's upside down, the right answer. And upside down doesn't count. Answer choice E. See how much faster this can be if we're being strategic? 100 times T minus G, 100 minus 50, over T, 100. Hey, look what happens. The 100 and the 100 cancel out. We're left with 100 minus 50, which is 50. And the first time we got a 50, that made us smile, but we might be a little bit more frowny face at this point. Why? Because I have 2 answer choices left. Yikes. If you're really rushing, you're running out of time on the test, and you have to guess on this one, you now have a 50-50 chance instead of a 1 in 5 chance of choosing the right answer. But the best way to overcome this obstacle is to just test again, but don't lose what you've accomplished already. So if you have more than one answer choice left, just ask, do I need to repeat the process? It's not a big deal. It's not going to be time consuming like the first time. You're already familiar with how the problem works, and you don't have to test as many answer choices, so it's not a big deal. Yes, we should continue testing, but when we do that, we remember from our scratch paper that we've already eliminated A, C, and D. So we're going to repeat this and only test 2 answer choices. And to repeat the process, this may sound obvious, but I'm going to state it. We need to choose different numbers. Repeating the process with the same numbers will not help. So to repeat the process, I just need to pick new smart numbers. Maybe things worked out a little too easy because it was a 50-50 split. So I'm just going to make one adjustment. I'm going to say that there are still T equals 100 tokens. But instead of 50%, I'm just going to change it and say that 40%. 40 tokens are green. And so my target answer is going to be 60. We don't test A, C, or D. Once they're eliminated once, they're eliminated forever. So all we have to do now is answer choice B, 100 times my new G value, 40, over T, 100. Well, that's definitely not 50. All of a sudden, we can see clearly that's not 50, is it? Nope. So we could probably pick E right away, but let's prove it to ourselves. 100 times T minus G, 100 minus 40, over T, 100. Yep, that's 60. That's my right answer, and it's E. What did we learn from this example? If the numbers you choose didn't lead you to only one right answer, which is possible just based on the fact that we're picking numbers somewhat randomly, all we need to do is test again with new numbers and the answer choices we haven't eliminated yet. Hello, Arif. Thank you for joining us. Moving into our final practice problem for today. This is going to show us how we can apply this same technique of making our own numbers up and plugging them in. We're going to apply that technique to quantitative comparison. Quantitative comparison questions, if you're just starting out with the GRE, this is an essential, super, super important question type on the GRE. We can expect about 7 of these questions in each math section. And they are all about relationships. So quantitative comparison focuses on the word compare. We're about comparing the relationship between the 2 columns. And here's the key. If the relationship between the 2 columns is always going to be the same no matter what, then the answer choices are A, A is bigger. B is bigger. C, they're the same. Those are easy to remember because of the way they're set up. But if the relationship between the two columns could ever change, sometimes they're bigger, sometimes one is bigger, the other smaller, sometimes they're equal, sometimes they're not. If the relationship could ever change, then we choose D. That's what D means. Alrighty, so think about this question. We need to pick out an X value and a Y value that satisfy the rule X is less than 0, which is less than Y. And we need numbers that are easy to work with to plug into quantity A and B. So pick out those numbers. While you're picking out your number, there's a great question in the chat. Is it always good to choose a number that's not equal on both sides? So before we chose like 50% and 50%. Not necessarily. Remember, we had the question where we had -1 for both R and T. Sometimes the number being the same can make things easy. Sometimes it doesn't work. That's just part of the randomness. But if you want to think ahead and be a little strategic, depending on the problem, picking numbers that you could possibly foresee an issue and avoid them is a great idea. From practice with this technique, you'll get a really good feel for what numbers are the most likely to lead to a good solution. So what did you pick for X and Y? Well, X has to be negative. Y has to be positive. We want them to be easy to work with. So our instinct might be X is -1 and Y is +1. Okay, let's try them out. Let's see what we get. Answer choice A, sorry, quantity A, not answer choice. Quantity A is negative X. X is -1 over Y, +1. So -1 divided by +1 is -1, and a negative of a negative, that just equals 1. Quantity A is 1. Hello from Nepal. Thank you for joining us. Quantity B is negative X times Y. So -1 times 1. Make that dot a little clearer. -1 times 1 is -1, negative of a negative. We get 1 again. So with this exact set of numbers we tested, both quantity A and quantity B come out to equal 1. So here's what we need to think about. It's possible for the two to be equal, right? We just proved that answer choice C could be true. But does that mean that it's always the case for every set of numbers? We should not assume. But we can eliminate two answer choices right away. It's not always going to be true that A is greater, and it's not always going to be true that B is greater. We proved that by showing it's possible for them to be equal. Possible. So how does plugging in help us decide on the right answer? When you use plugging in numbers on quantitative comparison, you should always plan on testing more than once. Always. The first time, just like we did here, you're going to be able to eliminate 2 out of 3 of the first 3 answer choices. Eliminate the 2 that were not the relationship you got. Then your goal is going to be test another set of numbers and see if you can get the results to be different. That's the key. Try to get the result to be different. If you can succeed, the answer is D. If you try everything you can think of and you can't get a different result, then choose the answer that you're getting again and again. So our goal is going to be to see if we can pick X and Y values to make the two not equal. So we're going to test again, round 2. Still a really good strategy for quantitative comparison. Excellent strategy. A lot of QC questions are very difficult to answer without plugging in some numbers for examples. We want to try to get quantity A and B to not be equal. Well, in A, we're going to divide, and in B, we're going to multiply. So those came out the same because we had 1, but let's pick numbers that aren't the same. Let's say X equals -2 and Y equals 5. We still have a negative and a positive, but multiplying and dividing these should come out with something different. Let's prove it. Quantity A is going to be negative 2 over 5, or 2/5. Quantity B is negative 2 times 5, or negative 10, positive 10. Details aren't important about what these numbers are. What's important is we prove the relationship is not always C. So if the relationship between the two ever changes at all, then you pick D. And we can confidently, absolutely choose D and get the point here. We have proven that the relationship cannot be determined. In other words, the relationship between the two changes. So we did another round of testing in both of these last two questions, and in neither case was it really a big deal because we already knew how to test because we had practiced it a little, and we were strategic in what to test. With multiple choice, we were only testing the answer choices that weren't eliminated yet. With quantitative comparison, we were testing with the goal of changing the result. So that gives us a strategic direction. Lots of great examples today. I hope you found them useful. And this was all extra stuff that we didn't work through because I just talked you through it. Okay. As we wrap up, I have a few more minutes that I can hang out live with you. I'd be happy to answer questions that you might want to submit through the comment section if you're watching live, or if a question comes to you later or you're watching the recording, you'd like to ask a question, you can email help@mangoush.com. Let them know you attended today's live stream and you have a question about it. We'll be happy to help you out with that. If you don't, here are some final points to take with you. Smart numbers means strategic, using numbers that are going to make things simpler for you to solve with. So when you're trying out this technique, we're practicing it, think about choosing numbers to make your life easier. You want your answers to be accurate and to come smoothly and quickly. The main point of today's live stream was that you don't have to actually use algebra to solve algebra problems. And for some of us who struggled with algebra in school, I hope that that is a major relief for you to hear. I hope that really takes a load off for you. And in our last couple of examples, we saw if the first numbers don't get you all the way to the final answer, that's okay. It's not a big deal. It's not a time to panic. And it doesn't mean you did anything wrong. It just means it's time to choose different numbers and repeat the process. It should be faster and simpler the second time. That's all I have planned to share with you today. Like I said, I'll stick around for a couple minutes to see if there are any comments or any questions. And other than that, I thank you for attending today, and I wish you success in your GRE journey. Ooh, when is the next live session? That is a great question. Let me check the calendar and look that up for you, because off the top of my head, I'm not sure. I think there will be one next week, but I'm not sure the exact date and time. So let me find that out for you. Let's see. Here and here. Should be on this document. Yes. Okay. So our next GRE live session is going to be on setting score goals for the programs you want to apply to. It will be next week on April 4th. So that's Tuesday at 9 a.m. Pacific time. So whatever time in your time zone today's session was, add 3 hours. And that will be the time of the next GRE live stream. You can also check out our GMAT channel, Mangoush GMAT. Many of the topics that are relevant there also apply to the GRE. For example, the strategy we worked on today can absolutely apply to GMAT problems. So the next upcoming GMAT live stream is going to be on April 6th, next week, Thursday about how to create your own study schedule. And then the next math section with me, if you want some more math help, is going to be on April 13th, working on word problems at the same time of day as today's live stream. You can also follow our socials. I know Instagram is always posting the next upcoming live stream. So Magoosh Official on Instagram should get you that info. You're welcome. Thanks for joining us, Emmanuel. You have a great day too. And for those watching on the recording, sorry you weren't with us here live today to chat in real time, but I hope that this video has been useful for you. Please, by all means, feel free to join us in one of our upcoming sessions. Like I said, on social media, you can follow along on Instagram and find out when our upcoming streams are on our GMAT and GRE pages. Like I said, many of the topics do overlap because question types are similar or use similar strategies on both exams. Looks like there's also going to be a live stream on our TikTok for Magoosh grad tests on April 3rd of next week. So lots of good topics coming up. I don't see any more questions or comments coming in, so I'm going to go ahead and log off. Thank you so much for joining me. I really hope that you do practice this technique that we've worked on. I believe there's great value in it, and I've watched it help many, many students. Try it out. Look for opportunities to use it on your practice problems and compare what you might think of as the traditional way to solve versus using the plugging in technique. See which one is faster, easier, more accurate for you, and get really good at using this technique, and it'll help you on a great deal of quant questions. Thanks, everybody. I'll see you later.